Hello everybody, welcome to the very first lesson of Pre-Algebra. So today we are going to talk about inductive reasoning, conjecture, and patterns. So let's see here. Many of you have probably had to use inductive reasoning, conjecture in your life to observe patterns, to figure out events or such things as that. Whenever you're making an educated guess based on experience or based on observing a pattern, that's called a conjecture. Which, whenever we use conjectures to predict what's going to happen next, that's called inductive reasoning. There is another type of reasoning which we're not going to talk about today, but in a future lesson we will. It's called deductive reasoning. But today we're going to just stick with inductive reasoning, which is just using conjecture to determine what happens next. So here we have our very first list. It looks like you start with an up arrow, then a right arrow, then a down arrow, then a left arrow, then again an up arrow. We want to find the next three terms of this list. Well, based on the pattern, up, right, down, left, and up, what would be the very next one if we had to make a conjecture, an educated guess on what would be the very next term of the pattern? Looks like a right arrow. I would say a right arrow would be next. And then if you had to find a second term, I would say a down arrow. And then if you had to find a third term, I'd say a left arrow. So the next three, based on the conjecture on the pattern here, it looks like the next three terms of the list would be a right arrow, a down arrow, then a left arrow. I think that one's pretty simple to see what's going on here. However, we also work with numbers. We do work with numbers here. So let's break out some numbers. Let us do that. Let's start with 2, 5, 8, 11, and 14. Okay. So we have a pattern of numbers here. We have 2, then 5, then 8, then 11, then 14. Look for any common threads between the numbers. It looks like from 2 to 5 we add 3. Looks like it's going to be plus 3 when we go from 2 to 5. When we go from 5 to 8, it looks like we're adding another 3. That'll be plus 3. To get from 8 to 11, it looks like we're adding another 3. That'll be plus 3. Then to get from 11 to 14, you add another 3. So basically, look what's going on between all the numbers in a pattern. That's what you want to do first. Once you've established that, if it's just a sum, that's easy. We could find the next three terms pretty easily now. To find the immediate next term after 14, it looks like all we're going to do is add 3. You would get 17. To find another term after that, the second term, you just add 3 to 17, you would get 20. And then to find the third term after that, add another 3, you'll get 23. So this particular pattern was just based on adding 3 to each term. You got to kind of read between the lines, so to say. Just figure out what's going on between each of the numbers to figure out what your next numbers are going to be. That one was not too bad. Let's do one like it here. We have 4, 8, 12, 16, 20, and then it just keeps going, of course. Well, again, you got a pattern. You got 4, 8, 12, 16, and 20. Are there any common numbers between each of the numbers? Well, to get from 4 to 8, it looks like you're going to add 4. To get from 8 to 12, it looks like you're adding another 4. To get from 12 to 16, well, it looks like you're adding another 4. To get from 16 to 20, it looks like you're adding another 4. Okay, well, it looks like each term, to get the next one, you're just going to add 4. Let's find the next 3 terms. So, to get the next term after 20, it looks like you're going to add another 4. 20 plus 4 is 24. Well, to find the second term, just add 4 to 24, you'll get 28. Then they ask you to find a third term. The third term, which would be adding another 4 to 28, that'll give you 32. So based on the pattern of plus 4, plus 4, plus 4, plus 4, you'll get 24, 28, and 32 for your very next numbers. Again, being able to read between each term to see what's happening to get from one term to the next, that's important. So far we've encountered addition, but lists do work backwards too. Oh yes, they do. Let's see here. For example, we got 54, 50, 46, 42, and then 38. And then it just keeps on going. So you got a list here of 54, 50, 46, 42, and 38. Read between each term what's going on here. So between 54 and 50, to get from 54 to 50, it looks like you're going to subtract 4. To get from 50 to 46, it looks like you're subtracting another 4. To get from 46 to 42, it looks like you're subtracting yet another 4. To get from 42 to 38, you subtract yet another 4. Okay, so it looks like it's pretty straightforward here. You're going to subtract 4 to get the next term. So we're going to find the next 3 terms in this list. To find the term after 38, you're going to subtract another 4. So 38 minus 4, that's 34. And then to find the second term, you'll take 34 minus 4, you'll get 30. Then to find the third term, you'll take 30 minus 4, you should get 26. So, based on the pattern of minus 4 from every number, your next 3 terms of the list should be 34, 30, and 26. Also pretty straightforward. Let's see here. Yes. Let's do one like it. 67, 61, 55, 49, and then 43, and then it just keeps on going. Okay. Well, we have a list here of 67, 61, 55, 49, and 43, then it just keeps on going. Well, let's look for what's going on between the numbers. To get from 67 to 61, looks like you're going to subtract 6. To get from 61 to 55, you're going to subtract yet another 6. To get from 55 to 49, you subtract yet another 6. And to get from 49 to 43, you subtract yet another 6. So it would appear, based on conjecture, that we're going to find the next 3 terms, but the very next term after 43, if we subtract 6, ought to give you 37. And then 37, after that, we want to find the next term. We want to subtract another 6, so 37 minus 6, well, that'd be 31. But we need to find a third term. So let's do 31 minus 6. That would be 25. So if we make a conjecture based on minus 6 between each term, you'll get 37, 31, and 25 for your next 3 terms of the sequence. So those so far are addition and subtraction examples. Now let's throw another type of list at you here. Let's see. 1, 2, 4, 8, 16. Then it just keeps on going. Let me write that a little bit bigger because I'm going to have to illustrate something here in a second. All right, 1, 2, 4, 8, 16, dot, dot, dot. Okay. So it looks like we have a list here of 1, 2, 4, 8, and 16, and it just keeps going. Well, let's look for what's going on between each number. From 1 to 2, it looks like you just add 1. From 2 to 4, you add 2. From 4 to 8, you add 4. From 8 to 16, you add 8. Well, it should be pretty obvious by now that this is not going to be a simple addition. Chances are, if you keep going up by different numbers each time, it's not a simple addition. Not at all. However, we could clearly see it's not subtraction because it's going up. But what about from 1 to 2? You multiply by 2, right? And then from 2 to 4, you also multiply by 2 because 2 times 2 is 4. Then 4 times 2 is 8. 8 times 2 is 16. We have multiples of 2. So we've established this is a multiplication list. We're going to make a conjecture and figure out the next 3 terms. So to figure out what the immediate next term after 16 is, it looks like you're going to multiply by 2. 16 times 2 is 32. But we're being asked to find 3 terms. Let's find the second term we're being asked to find. 32 times 2, that's 64. Let's find yet a third term. Well, we got to multiply by 2. 64 times 2, that's 128. Okay. So, it looks to be that based on the pattern of multiplying by 2 between each term, your next 3 terms would be 32, 64, and 128. So, also look out for multiplication. Let's do one like it. We have 2, 6, 18, 54, and 162. Then it just decides it's going to keep on going. Alright. Well, we look at this, we can clearly see this isn't going to be a normal addition list. It's clearly not subtraction. Let's try multiplication. Because we have 2, 6, 18, 54, 162, and it keeps on going. Well, it looks like to get from 2 to 6, you can multiply by 3. To get from 6 to 18, you can multiply by another 3. To get from 18 to 54, you can multiply by another 3. To get from 54 to 162, you multiply yet again by another 3. So it looks to be that if we want to predict this pattern for the next 3 numbers, we're going to have to keep multiplying by 3. So to get the very next term, you're going to take 162 times 3. Looks like that'll give you 486. So the very next term of this list would be 486. Then we'll find the next term, 486 times 3. Well, that'd be 1,458. Then to find the third term, the last term we're being asked to find, multiply by another 3, you'll get 4,374. So you have, let's see, based on multiplying each term by 3 to get the next term, you'll have 486, 1,458, and 4,374 as your next 3 terms. So we've seen examples now of multiplication. Of course, there's division ones we can do, but I'm not going to because I think we got some more important lists to work on, such as these next 2. Let's say we have 2, 5, 9, 14, and 20. And then it just keeps on going and going and going. Alright, so we have 2, 5, 9, 14, 20, and it just keeps on going. This is different, because to get from the first term to the second term, to get from 2 to 5, you add 3. To get from 5 to 9, well, you add 4. To get from 9 to 14, well, you add 5. To get from 14 to 20, you add 6. Okay. So we can clearly see this is not a normal addition one. This is definitely not subtraction because it's going up. It wouldn't work out to be multiplication either. This is another type of list where between each term it goes up by a number, but you keep adding one more. You just keep adding one more to it. So we go up by 3, then by 4, then by 5, then by 6. So we want to find the next 3 terms. It looks like to find the term after 20, based on the pattern, we're going to have to add 7. So 20 plus 7 is, well, 27. Because to get the next term afterwards, you would add 7. So guess what? It looks like to find the second term we're being asked to find, you're going to have to add 8. So 27 plus 8 is 35. Well, we still have a third term to find. It looks like to find the third term, you have to add 9 to this one. So 35 plus 9 is 44. So based on the pattern here, you would have the next 3 numbers would be 27, 35, and 44. So that seems pretty self-explanatory also. You're adding one more. You keep adding one more to what's already there to find the next term. I have another one like it. Okay, what about 3, 5, 9, 15, 23, then it just keeps on going. Well, this is also another, it's sort of similar to the last one we did. To get from 3 to 5, you got to add 2. To get from 5 to 9, well, you got to add 4. To get from 9 to 15, you're going to add 6. To get from 15 to 23, you're going to add 8. So it looks like between each term to get to the next one, you keep adding by an even number more than the last one to get to the next term. So based on my conjecture, based on the pattern, in order to get the term after 23, we're going to have to add 10. So 23 plus 10, well, that's going to be 33. Which means to get the term after 33, we're going to have to add 12. 33 plus 12, well, that's 45. Which means to get the term after that, we're going to have to add 14. So 45 plus 14, that is 59. So based upon the pattern here, going up by an even number every time we add, you're going to have 33, 45, and 59, because it's going to go up by 10 from 23, by 12 from 33 to 45, and by 14 from 45 to 59. I guarantee you, if we were to take it a step further, the next one would be 16, which would put us at 75, but we're not going to go that far. Alright. So those are types of terms to look out for. There is one more I wish to discuss with you here. So we have 1, then we have, let's see, 4, 9, 16, 25, etc., etc. Okay, so this one here, we have 1, 4, 9, 16, 25. Well, it doesn't look like a classic addition one, doesn't even look like classic multiplication. But all these numbers have something in common. What is that, you might be asking? Well, let's say, hypothetically, each of these numbers, like each number of the term is raised to the second power. So for example, the first term raised to the second power, the second term raised to the second power, the third term raised to the second power, the fourth term raised to the second power, and the fifth term raised to the second power, and it just keeps on going and going and going. We notice that because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So it is also very helpful to know your exponents. It's very good to know your basic exponents. Now we want to find the next 3 terms of the sequence. What I'm going to recommend we do, of course, is first do it as the squares. So if you're going to square the next term, it looks like 6 squared would come next. And then the second term after that would be 7 squared. Then the third term after that would be 8 squared. But to put it the way the list wants it, we need to take each of these numbers to the second power, which would break down into 6 squared is 36, 7 squared, that's 49, then 8 squared, well, that's just going to be 64. So it looks like the next 3 numbers of the list here are 36, 49, and 64. So it also helps to know shortcuts and to know what some numbers to the second power are. And sometimes the ones to powers can be the hardest examples, but lists like that do exist. I just want to make you aware of that. So really, that is all I have for this lesson on finding lists and patterns. The next lesson we are going to do is going to be numbers and expressions, which is going to feel an awful lot like a review of basic math, but I mean, there's a little bit new in there because I got to teach you how to put words into numbers and make it an equation, but there is a lot of review in the next lesson, so stay tuned for that. I hope everyone has a good day. Take care.